Neurodiversity refers to the natural variation in how human brains are wired and process information. Conditions like autism, ADHD, dyslexia, and others are often framed only in terms of challenges. But research increasingly shows that these different cognitive profiles can also bring exceptional strengths, neurodiversity superpowers, that have fueled some of history's biggest breakthroughs in science, art, and innovation. The paradox is that traits often seen as limitations in one context can be extraordinary assets in another. Take autism, for example. Some autistic individuals excel in pattern recognition, attention to detail, and sustained focus on specific interests. These traits can be invaluable in fields like mathematics, data analysis, molecular biology, or software engineering, where spotting subtle patterns can unlock new discoveries. The intense deep dive approach common in autism has parallels with the kind of persistence needed to crack complex scientific puzzles. Think of it as cognitive endurance in action. ADHD, on the other hand, is often associated with distractibility, but it can also foster rapid idea generation, risk-taking, and creative problem-solving under pressure. Many with ADHD show exceptional adaptability, able to connect seemingly unrelated ideas and thrive in high-stimulation environments. These traits can be a huge advantage in entrepreneurship, crisis management, or fields that reward innovative leaps over incremental steps. Dyslexia, typically framed around reading challenges, often comes with strengths in spatial reasoning, big-picture thinking, and visual creativity. Dyslexic thinkers have been overrepresented in areas like engineering, architecture, and design, where seeing complex systems as interconnected wholes can lead to elegant, unconventional solutions. Historical figures like Leonardo da Vinci and modern innovators in tech and design have spoken about thinking in pictures, a trait linked to these cognitive profiles. Why does neurodiversity produce breakthroughs? One reason is cognitive diversity itself. When teams bring together people who literally think differently, they're less likely to fall into groupthink and more likely to challenge assumptions. A problem approach from multiple mental angles stands a better chance of yielding an innovative solution. This is why forward-thinking research labs, tech companies, and creative industries are actively working to include neurodiverse talent not just as an equity measure, but as a strategic advantage. But the takeaway is clear: different minds don't just bring different skills, they bring different maps of reality. And in science, technology, and art, sometimes the shortest route to a breakthrough is through a landscape only one kind of mind can see. The challenge for society is to build environments, educational, professional, and social, that let these superpowers shine rather than be suppressed. Neurodiversity refers to the natural variation in human brain wiring and cognitive functioning. It encompasses conditions such as autism, ADHD, dyslexia, dyspraxia, and others. Scientists view these variations not solely as deficits, but as different information processing styles. These differences can offer distinct advantages in perception, problem solving, and creativity. Emphasizing strengths alongside challenges can shift how society views cognitive differences. This framework promotes inclusion and innovation by valuing diverse mental approaches. A dyslexic entrepreneur might excel in big picture thinking and strategy, despite difficulties with spelling. Neurodiversity is like having different tools in a toolbox. Each is best for a specific kind of job. Some neurodivergent individuals excel at spotting patterns others overlook. This heightened ability may stem from differences in sensory processing or attention distribution. Such skills are useful in fields like data analysis, scientific research, and cryptography. Recognizing anomalies or subtle trends can lead to early detection of problems and novel insights. This advantage often appears in tasks requiring sustained focus on detail. The brain's unique wiring makes certain patterns stand out more clearly. An autistic data scientist identifies a hidden correlation in genetic data that others missed. It is like having a radar tuned to pick up faint signals invisible to most receivers. Individuals with ADHD or similar traits can experience intense focus, known as hyperfocus, on tasks they find engaging. This allows them to work for long periods without distraction when fully immersed. Hyperfocus can lead to deep expertise in specific areas of interest. The ability to sustain attention on passion-driven projects can produce exceptional output. However, this focus is often situational and linked to intrinsic motivation. Harnessing it effectively requires aligning work with personal interests. A game developer with ADHD spends 16 hours perfecting a complex game mechanic in one sitting. It is like a laser beam, highly concentrated and powerful when aimed at the right target. Neurodivergent thinkers often approach problems from unconventional angles. Differences in cognitive pathways can bypass common assumptions, revealing new solutions. These approaches can disrupt established methods in productive ways. Creative breakthroughs often come from combining disparate ideas or reinterpreting existing knowledge. Such thinking thrives in environments that encourage experimentation. The diversity of thought can expand the range of possible solutions. A dyslexic inventor designs a tool based on a visual spatial idea overlooked by text-focused colleagues. It is like taking a side road no one else noticed, only to find it leads directly to the destination. Neurodivergent individuals may process sensory input more intensely or more subtly than the neurotypical average. This can enhance perception in areas like color differentiation, auditory detail, or tactile sensitivity. These heightened senses can be advantageous in design, art, or scientific observation. They can also provide unique insights into user experience or product aesthetics. Sensory differences shape how information is gathered and interpreted. This can lead to novel discoveries based on sensory cues others miss. An artist with heightened color sensitivity creates palettes that evoke stronger emotional responses. It is like having a microscope built into your senses, revealing layers others cannot see. Some neurodivergent people have exceptional memory abilities, such as vivid episodic recall or deep retention of niche knowledge. This can be linked to variations in brain connectivity and hippocampal function. These memory strengths can support expertise in history, science, technology, or art. The ability to recall precise details aids in pattern recognition and creative synthesis. Such memory can also enhance storytelling and teaching. It provides a stable foundation for building complex, interconnected knowledge. An autistic historian can recall specific dates and events without needing notes. It is like having an internal library where every book is always available and perfectly organized. Some neurodivergent profiles include a higher tolerance for uncertainty or unconventional choices. This can drive innovation by encouraging exploration of untested ideas. In fast-changing environments, the willingness to challenge norms can be a strategic advantage. Such risk-takers can lead to breakthroughs that cautious approaches might miss. While not all risks succeed, the successful ones can redefine entire fields. This trait works best when balanced with informed decision-making. An ADHD entrepreneur launches a new market concept that disrupts established industry leaders. It is like being willing to sail into uncharted waters in search of new continents. Neurodiverse teams benefit from combining different cognitive strengths. One person's detail orientation may complement another's big-picture vision. Such complementarity can improve problem-solving by covering a wider range of perspectives. Effective collaboration requires mutual respect and role alignment. Organizations that leverage these differences can outperform more homogeneous groups. This approach turns diversity into a functional advantage. A team pairs a hyper-focused coder with a visionary designer to create a groundbreaking app. It is like building a bridge with steel for strength and cables for flexibility. Both are essential. Viewing neurodiversity as a source of competitive advantage reframes inclusion as more than a social goal. It becomes a deliberate strategy for innovation and resilience. Companies and institutions can design processes that maximize diverse strengths. This includes flexible work arrangements, sensory-friendly spaces, and alternative communication methods. When diverse minds are supported, their unique insights can drive progress in unexpected ways. Embracing neurodiversity can thus expand the boundaries of what is possible. A tech firm adapts its hiring to include alternative assessment methods, leading to a surge in patent filings. It is like widening a river channel, allowing more varied and powerful currents to flow through.